Hey, what's up everybody? Welcome back to another 3D Thursday. I'm Noe Pedro Ruiz, designer here at Adafruit.
And I'm Pedro Ruiz, the creative tech here at Adafruit, and every week we bring you 3D printing projects, news stories, slicing techniques.
And goodness, we combine DIY electronics with 3D printing to help you guys in your projects. So, let's take a look at what's on the show.
That's right, every week we have an assortment of lovely segments. We start off with what are you prototyping? It's when we take a look at some of the behind the scenes projects of what we're currently working on.
Yep, always working on some cool stuff. And then we'll jump out into the internets. We're gonna scurry the nets every week to bring you guys some 3D printing news. A lot of cool projects this week, every week.
After that, we'll jump into this week's project video.
Oh yeah, very fun one. Fun and easy, relatively easy. And then we'll take a look at a layer by layer. So this is a very special one. You've been playing around with the Ember.
Yeah, so we're going to take a look at some of the slicing techniques inside of Meshmixer. So we'll look at some of the settings that I found that work, make things stick to the bed real nice. So we'll take a look at that in the end of the show. Stay tuned for that.
Okay, very, very cool. Right before we start, we want to share with you guys a coupon code. Discount, 10% off.
That's right, works on everything 3D printing related. Electronic goodies. Doesn't work on software or gift certificates. Use the coupon code Gamepad
at checkout.
That's
right. Okay, with that out of the way, let's go ahead and take a look at the overhead because I'm excited to see some cool new prints that you got on our lovely new Ember printer. If I could get the thing. Okay, ready? And go.
Yeah, so this are some of the cool prints Pedro, that we are getting out of the Ember, which is the SLA DLP resin-based 3D printer. As you can see, it's got a lovely transparent, almost acrylic-looking
surface. Yeah, so this is clear resin that comes with the Ember machine, and it comes with several bottles of it. And it's been quite the experience so far to get a 100% fully functional part. So can you tell us a little bit about the workflow and maybe what's different about it?
Yeah, so the workflow is completely different than the FDM. With FDM, you can quickly just go over and snatch your part off the bed. With this, you gotta wear like gloves, like
it's a very
eyeglasses.
Process. You need a lot of area to process this part. When you're printing with clear resin, everything gets messy. Everything you touch, all your tools.
Yeah, you got to be very aware of your actual workflow of what you're gonna how you're gonna touch things in order.
Yeah, there's a lot of that, and I think that's one of the reasons why you're not seeing a lot of people posting images of it because you got to use both hands to mess with the chemicals. So
yeah, one of the ironic things too, we have Google Glass here, and I tried using that. All the voice commands work beautifully, and then after 2 minutes of using it, it overheated and I couldn't use it.
It overheats. I've tried many times in all of my projects to use the Google Glass. Why did this turn into like a, hey, how Google Glass? Show us some other parts.
Because this would have been perfect for showing you guys the workflow for that.
You have other parts though, show me.
Yeah, so this is the coin jewelry project that we worked on, and you could just tell the surface quality on this.
How did you print this? Like with the support material, how is it printed orientation-wise?
Yeah, so orientation-wise, the supports were actually holding on to this part of the edge. So it's printing like that, and then this weird little
branch?
Sort of like a branch that goes through here and held the rest down here. But it's really cool the way it looks. I like the tolerances fit with the PLA here, so you can see transparency of the inside, what a circuit would look like.
Oh man, yeah. So go ahead and try that out. What does it look like in terms of diffusion?
Oh, diffusion looks pretty gnarly on that.
Oh my god, so it looks like ice. This is such amazing quality. You printed at 25 microns, right?
25 microns took about, I think, 2.5 hours to print.
Okay.
And then this is really cool for projects that involve tiny little things like our Pi camera here. You see this cool little enclosure that we got off of Thingiverse.
You can go pretty close. Yeah.
Let's see. You can just see the quality.
Do another one of those.
Let's see. Try to wipe that again.
I'm about to hit manual here in a second.
Yeah, go ahead.
Okay, dokie. There you go. Go as close as you can. you can really see, you can almost make out all of the text and labeling on the PCB. Go ahead and show us the back there. You can see all the little components that are surface mounted to the PCB there. It is just a phenomenal machine when it comes to detail. And then printing and orienting. Let me put it back to auto.
On that.
Yeah. So when it comes to the transparency of the material, it's really dependent on how thick it is. So the thinner, of course, you get, the more you're going to see through it. So we're going to be experimenting a lot with these, with the Ember printer, and I think
got a couple more cool projects that we're working on. So for your keyboard, Colin actually requested this one.
Colin Cunningham.
So for our keyboard here,
Lab.
You can switch out your key. So just build a new one. We got one we're prototyping here. Here's a cool little skull. I don't know if you can see that. Probably not.
Yeah, try that again. Oh. Here, I'll switch it to the full on zoomed up. Okay.
And if you follow me on Instagram, you can see closer photos of that. But yeah, check out the quality. It didn't come out 100%. Had to mess with the orientation and support material on that, but you can totally see the high quality that you can get out of this. Yeah, that's a good sort of preview of what it looks like when it doesn't look completely 100%. So that's pretty cool. Okay. Yeah, so that's some of the cool things we've been prototyping with the Ember. You got some cool things for an upcoming.
Yeah, so Adafruit is coming out with a contest, coming soon contest. This is a Droney Awards 2015 contest. So we are working on a very cool 3D printed trophy. And this is our Droney mascot that was designed by Bruce Yan. He's our creative director here at Adafruit. And it's a really cute little mascot. He's a little gumdrop looking drone. So he's got 4 different little arms and he's got spinning propellers. It's a 10-piece design that snap fit together. We're gonna print, the goal is to print it in copper fill and to do our tumbling polishing technique so it comes out looking like a fully copper, lovely looking gold-ish. So be on the lookout for that. Future project.
All right, cool. Now let's move on to some news.
You want to move on to the news? Okay. We'll do some news. All right, so first up in the news, we got a new update from James Bruton. He runs the XRobots YouTube channel. And this week he is prototyping and working on his 3D printed drone. It's a 3D printed R2-D2. It's almost like a drone, but
it's a droid.
It's a droid. Thank you. This is amazing because the full thing is 3D printed. It is multi-layered parts that are acetone welded together. And in this tutorial, he goes through sort of all the parts, and he's figuring out all the mechanics for converting the droid to go from two-wheel to a 3-legged mode. So very, very cool. A lot of different techniques being used here. And this is the scale of this project is pretty large. He's using big LiPo batteries to sort of prototype the motors to see if everything is, if everything holds up well. He's using a Lazy Susan type mounting brackets on the sides there, and a sort of a linear guide system in the middle there to get the motor to go from 2-wheel to 3-wheel. So very, very cool. Definitely check it out on his YouTube channel. We also got a link for you guys in the blog. And yeah, that's a very, very cool project. Every week, James comes out with an amazing update to his projects. Very mechanically design driven, and a lot of electronics as well.
And a lot of wearable, mechanically design driven designs. I really like watching the way all of the prototyping fits all together.
Yeah, because you get to sort of see him as he's coming out. If things don't work out, he'll go through it.
I like the way it's all modular, so you can go back and sort of redesign specific parts that don't work out.
That's right.
Really good on that.
Very cool. Alrighty, next up.
Next up, we got Eddie Plus.
Eddie Plus.
An awesome little self-balancing robot available on Thingiverse. Has rechargeable batteries, Wi-Fi enabled. You can remote control it through iPhone app, right?
Yeah, he's working on an iPhone app. This is a really cool project. It is completely open source, like you were saying. Who's it by on Thingiverse?
This is by user Diabetes Monster?
Diabetes Monster, that's right.
Diabet monster.
Yeah, so some of the electronics, he's using the Intel Edison board. I haven't seen many projects with it. This is a really good project with it. He's also using some components from Pololu and SparkFun, so very, very cool. Not only is it self-balancing, but you can also control it, like you said. And he's sort of a dynamic balancing robot. As you add more weight to it, he tends to figure out how much weight's on them, and he sort of figures out how to balance himself.
Yeah, this is a very killer project for, in terms of marrying 3D printing and electronics.
Yeah, it is one of the coolest projects. I like that the design of it looks kind of like that character from Futurama, with his little clamps.
Stabber dude, yeah.
Little stabber guy. So very cool. It's available on Thingiverse. You can download it now. And what's even cooler is he has a full build and guide that he put together on Google+. So you got the link for you on his description, on his Thingiverse page, and we also got the link in the description below.
Check out this cool project. Build one yourself. Next up, we got Meshmixer tutorial by Angus.
So this is Angus. He runs the YouTube channel Maker's Muse, and definitely check him out because he does a lot of cool tutorials on getting video game assets and printing them out. He's got a lot of experience with SLA printers. That's typically what he tends to work with. And in this tutorial, he's looking at how to fix color meshes that have holes to make a watertight manifold design. So Meshmixer is definitely the best tool to do it. And he goes through some of the little quick tips. If you do it sort of the way that everybody knows to do it, it doesn't really retain color data. So with this new approach, you're able to quickly select all the holes in the perimeters of your mesh, and then you can heal it, and it does this really, really smooth finish. And not just on that, but you have control over it too, like to bulge it out, pucker it. It does a really great job on smoothing out color data. So here you can see the little polka dot bunny. The polka dots come out really well. You could barely tell that it was sort of clone tooled, healed, stamped tooled together. So very, very cool technique. Definitely useful, and you should definitely check out Maker Muse's YouTube channel for more. He does one about every week, so very cool.
That's right. Definitely check out the cool techniques on doing your edge loop selection there.
Yeah. Okay. Next up.
Next up, we got NeoPixel freeform light structure.
Yeah, this is a really cool, easy project. Who's it by? Tell me some details on it. While I put this up.
Is by user Fred Bartles on Thingiverse. Has interlocking connectors with clips to hold the NeoPixel LED strips. It has different shape diffusions like crystal rocks, and it uses a dowel to hold up the entire structure.
Yeah, this is a really cool one because it's, like you said, it's free form, so you can make it into any type of shape. You could even take it a step further and add servos to make it sort of move.
Yeah, I really like the simple design, just using the NeoPixel strip to create an awesome little structure of it sort of looks like an art piece here.
It is totally an art piece. Yeah, so if you're looking to get into LED sculpture art, 3D printed parts are definitely the way to go.
All right, next up we have an Armband voltage meter.
Yeah, this is really cool. This was, tell me who designed it?
So this is by Drano Web on Thingiverse. It took about an hour to design, and what it does is uses a DC volts to measure your voltage here.
Yeah. This is like an hour job that's like, you know what? I don't have 3 hands. Let me make something that I can fix in an hour and make it wearable. So this is one of those really cool, useful projects where you're like, you know what? I got this problem. I could probably design it and print it within an hour, and he totally did. And it's just an off-the-shelf voltage meter that you can get anywhere. And then you just sort of take it apart, make your own enclosure, and make it wearable, make it work for your needs. It's really, really cool.
It's definitely what 3D printing is all about.
It totally is. Again, you can download it on Thingiverse. It's free.
Yep. Get the STL files to print your own.
Okay. Next up.
Next up, we have an earring that's an ear for a ring.
Yeah, this is a weird instructable by user Malarkey.
Yeah, this is an instructables on how to sort of combine the 2 meshes together.
Yeah, so this isn't really like self-design. It's more like, let me take 2 pieces that are already on Thingiverse, mesh them together, mix them together with Meshmixer, and make a very cool, sort of strange, freaky type of project.
Yeah, so this is the final product here. Looks pretty good. Printed on the PrinterBot Simple metal.
Yeah, it's very small
quality for that.
Yeah, it really is. I don't think there's much support material there, but it is indestructible. You can check out all the steps on how to make your own if you'd like.
Yeah, and the files are available on Thingiverse.
Yeah.
He's using, like we said, 2 different objects to merge together.
Yeah.
It's one of those weird, strange, but it has a why not factor to it.
Yeah, it's like, why not?
Looks kind of freaky cool.
Yeah, it's cool. Okay, next up.
Next up, we got a Nightingale bow from Skyrim.
Yeah, Nightingale Bow. This is from Skyrim. It is fully 3D printed. Tell me who's this buying.
This is from Marco Antonio, who was looking for a job. He saw a posting on My Mini Factory. It took about 7 to 8 hours to design inside of SolidWorks. He split it up in 12 different pieces, printed it on a Rep 2. And it sticks together like a jigsaw puzzle. You can kind of see the little puzzle pieces, like right there in the black and the red, where they connect together.
Seems to be a good way to get pieces to have good friction hold without any glue and stuff.
And for the bow, he's using Ninja Flex filament. So that's what he's using as the string there.
Yeah,
white Ninja Flex.
Yeah, very good use case of just the filament as itself, and not actually have to print anything. Just use the filament.
Yeah, so this took about a whole roll of spool.
That's, I think, about half of spool.
Oh,
that's
yeah,
500 something grams.
Yeah, it says here 578 grams it took. And yeah, very little post-processing and support material. Looks really cool.
Definitely we want to make one. Look at that. Very cool,
awesome.
Very cool. So it's on My Mini Factory. They're definitely one of the best repos. Yeah, one of the best curated repo sites that they're all about the cosplay. Very high quality prints. They actually print everything out themselves and ensure that everything is printable. We have a couple things up there too on our profile. We got an Adafruit profile as well. So check that out. You can download this today, print it out, and more days. It's taking a couple days. And that's going to be the news, I think.
Yeah, and don't forget, if you want to pick up any supplies to make any of these cool projects, don't forget discount code Gamepad, get 10% off.
I wonder why it's Gamepad. Well, you know what? I think it's time to jump into today's video. Pedro?
Let's check out this week's not tutorial.
It's kind of a tutorial.
Project.
It's a project. So this is a DIY 3D printed Bluetooth gamepad. Very, very fun project that you can put together. This is one of those ideas where it came from another idea. I was going to make a Pocket Pi using the Raspberry Pi A+, and I ended up just making a standalone Bluetooth gamepad, which is really, really fun. It's using the EasyKey Bluefruit module. It's basically a breakout board designed for making custom keyboards. Really easy to use, no program required. And of course, to build this, you're going to need a couple tools. Soldering iron, some pan of ice, some Haku stuff, Haku pliers and cutters. And the featured product is really the Promo Proto PCB, which is a little PCB that has tons of holes in it, so you can make your own custom circuit. So in this one, I'm using the half size Promo Proto, and it works really well to make this layout. It has just enough to make the little Nintendo retro-esque game controller. So it's got A, B, the D-pad, and then select and start. It's really easy to solder this project, and I think this is going to be a good project for people that want to learn how to solder. So that's really cool, because there's quite a bit of solder points involved. But the more you do it, the more fun and easy it becomes, especially when you have the right tools to do it.
Yeah, and the reward you get is a physical object you can play games
fun.
with.
It really was super fun to play with this. So
you can design your own layout.
Yeah, so you're going to solder that up, and one thing you'll know is you can cut the PCB board. I had to cut the PCB board and take off 2 of the corner bits because the enclosure is so small and it has these standoffs in the corners that I just couldn't fit the PCB in there. So you're going to have to saw this off. I of course recommend doing it in a well-ventilated area, wearing your safety goggles and safety things. But that's probably the hardest part of the project, to saw the thing. It's, you want to be careful. I'm using 30 gauge silicone-coated stranded wire. That's definitely what I recommend using on most of our projects. And you'll definitely want to try to use the shortest amount of wire possible, since we're doing since we're just connecting all the buttons in series to ground. You'll want to use as little wiring as possible so that you have no excess wiring, because if you do, it's going to be hard to fit it in the case. So it's a good it's
practice
a good project.
On making
on making the smallest wires possible. So once you have your buttons all soldered into place, we're going to work on the power circuit. So it's using a slide switch. We're just going to solder 2 wires to it and then secure it down with heat shrink tubing. Now, those 2 wires that we just soldered onto the slide switch, they're going to connect in between a micro LiPo charger and the easy Bluetooth key, so that we can turn off and on the circuit. So it's going to get soldered into the VIN pin on the easy key and the BAT pin on the LiPo charger, and then we're going to create a wire for the ground to connect ground to ground, so that the 2 devices can work. So the micro LiPo has a JST connector on it, and the battery is a 500 milliamp battery, which is going to last a really long time. That already has a JST on it, so you just plug it into the battery, and you can charge it via USB. So once that's all ready to go and working, you're going to need to solder the button inputs into the input pins on the easy key, which is pretty straightforward. Now, the order doesn't matter too much on the easy key because you can reprogram them with the little GUI app, which is really easy, but you do want to make sure that you solder into the buttons that are, that have the right polarity, because you can't just have them both be in the same spot. I have a guide on the Adafruit Learning System, so you can check that. It's actually been out for a couple weeks now. We tend to get those out a little bit earlier so people can get the products and get some experience with it. Yeah, and test it out. Now, one of the next things we need to do was to set up another button, and this one's going to be a Bluetooth pair button, so we can easily switch between devices, because it's such a fun device. You don't want to be locked down to one device. You want to be able to switch between devices, so that's what the Bluetooth pair button is going to do. You just solder 2 wires to it, and on the easy key, it's going to get soldered into the input 3V and the input PB, which stands for pair button. So that's pretty straightforward, and you don't want to have it too long, of course, but this button is definitely essential to the build. Now, once the build is done, you're going to want to, of course, test all your wiring and make sure it works. I recommend testing it out before sealing it into the enclosure, of course. That's how I work, and that's how most people should work. So test it out, make sure it works. I designed the enclosure in 123D Design, and I have the STL and the 123DX file, which has all the original solids, so you can modify it. Let's say you wanted to make a one-handed version. That could totally be done. You can take the design and modify it any way you like. And since the parts are really small, they're going to work on most 3D printers, like the printer bought Metals, and it has a small build volume of 150 by 150. So anything around that is going to work really well. You don't need any support material to print this. It prints straight flat out. It's already oriented for you. And you can print it in many different colors. It's a 2-part design. You got the main enclosure in the bottom. And then I made this little cool cover just to give it some color variation, so that's cool. Now, the buttons themselves, they're actually printed in NinjaFlex because, NinjaFlex, this is the best use case for it. In this particular one, I used SemiFlex to see which one would sort of hold out better. It turns out I like the regular NinjaFlex more because of the way it's more squishy and more grippy. So the 2 components are going to get mounted to the bottom enclosure with 2 number 440 machine screws. They're the flat kind, the flat Phillips machine. And the Bluetooth button itself is going to get held in place in that little platform with some glue. And the Permaproto itself gets mounted on top of the components, and you just fasten it together to the 2 standoffs that are on the bottom enclosure using the same number 440 size machine screws. And the battery itself, it's going to just wedge it in between the Permaproto and the bottom cover. There's just enough room in there to fit it into place. But if you wanted, you could
some gaffer's tape around it, give it some cushion.
Yeah, though I'd be wary with that because then it's just going to be really tight in there.
Yeah,
so
that's right.
That's one of the reasons why I didn't. But it seems to work out really well if you manage your wiring and you clip off all the ends. You don't have any sharp edges. It's going to be pretty well, and especially since inside this case, it's not going to harm it by squishing it or anything. So you seal it up together. One of the last things you want to do is make sure you pull out that slide switch and fit it in the clips before you insert it in at an angle and close it up. But again, all the steps to build this project are on the Adafruit Learning System. I spent some good time on making sure that each step is in there and everything's photographed. Very beautiful.
Yeah, it takes a lot of time to build these.
It does, especially to document it well. So you can print it in any color, of course. NinjaFlex for you.
And regular PLA would work too.
Regular PLA, probably not because of because it needs to be stretchy. If you you were to use hard plastic, all the buttons would click at the same time. So you actually really need NinjaFlex in order to do this, or any other type of TPE material. So I've been playing with it for the past, the last week I was playing. I had to stop because it was just there's just too much playing going on. Too much
so it works on Android devices, works on your phone. Yeah, use it like hook it up to the Apple TV and just use the big TV to play video games on. It's really cool.
It's a very, very fun one. And that's the project. Again, check it out on the Adafruit Learning System. You can build yours today. You can get yourself
coupon code, get a discount on some NinjaFlex PLA, a printer. Any of the tools you might need to build such cool little project.
It'd be cool, like
so many uses.
Yeah, it'd be a cool belt if it was on there.
Oh yeah, or like on a glove or something.
And the Nintendo glove right here.
Use the discount code Gamepad, get 10% off. Expires at 11/59.
Yeah.
Doesn't work on software or gift certificates.
That's right.
Now let's go ahead and take a look at a layer by layer. This time it's a little bit different. It's a layer by layer on the new Ember 3D printer, the workflow on setting up some support material. So to start off, we're gonna start off using the print settings, and this is just getting right to the point how to do the setup. So you can just select the printer that we're using, and it's the Ember here. It'll set up your build plate area. I've tried setting it up in like Simplify 3D, and because of the support materials won't export, I'm stuck having to use Meshmixer for this. Okay. So the orientation doesn't work too well, like doing a big old flat space like we have at the bottom there. So I attached the pegs onto that since it was going to be, one whole piece anyway. So we want to get the less amount of surface area to touch the bed. And if you pause that real quick, what this is, it's going to be printing upside down. So it sort of reorients it for you, so you're not, having to think upside down. Oh, wow. Which you still kind of sort of are, because that's the top of the bed there.
So you will have to think about that upside down.
Yeah, hit play again. Sure. One of the support generating settings that I found made a giant difference in whether it stuck or not was the tip diameter for the branches there. And I found that around 0.3 to even up to 0.5 really generates a sturdy material that won't let go of the model while it's printing. Yeah,
because what I noticed is that when it's printing, it has to move away from the light and actually sort of
it's the peel technique that it's using. So it'll actually move away and sort of rip the model off of the
it does feel like the screen. It feels like it's swishing through the.
It's creating wake as it goes through, and so, it's not super thick, but it's viscous, so it can, if little pieces snap off, it can, crash into it and sort of swoosh around with it, get stuck like a filter or something.
So that's really what you need, is just really strong support material that's nicely fitted into it.
Okay. You'll definitely need some Haku plier, the flat flush diagonal cutters that sort of cut some of this off, but it's better to have that than it not print at all.
It didn't look like it was on the bed. Did you have to lay it flat on the bed?
It's just a bug right now inside of Meshmixer, so when you hit finished, if you scrub back just a tiny bit.
Yeah, that's what I noticed. It was like, why is it off the bed?
Yeah, I know. That's one bug that sort of annoying right now, and you can't look underneath the bed either.
So what do you do to fix it?
So you just hit OK, accept the support material there. You just hit done. Okay. Don't hit convert to solid.
Ooh. So you have to keep it separate. Oh, cool. Okay.
So here's just techniques on creating your own structures. You'll hold down the command key. I think it's the control key on Windows.
Are you in some sort of mode?
Yeah. So we're inside of the support. We're still inside the support generator option. So just clicking around is what's gonna start generating the little branch structure. So you just hold down the command key to sort of add more. And the trick here is to have it just wait until the little shine goes on there. Otherwise, you're gonna get support material and you don't want, that's a waste of material and it might fail. So you just want to wait until you get the little shine when you're sort of generating your support material there. Okay. So once you're done with all that, it should move it back up. Hopefully they fix that bug. And to do your slicing right now, you can generate it by using the amberprinter.com website.
This is the only way to do it, right?
There's other ways, but it's a little bit more messy. You have to like generate like a bunch of stacked files and create like a target. It's just easier doing this way, I think. So there's a cool little preview that the Ember site gives you when
so you
doing
upload it to the site and it slices it through their cloud, I believe.
Yeah. So here, this is actually what Ember should actually do. Give you ability to hide the platform so you can see where your support material is going. And then these advanced settings here, you can just take a look at what's in here. I didn't really change anything in there because I don't know what any of this stuff does yet.
We don't know yet. No,
there's some documentation on their site, but I just leave it at the PR 480 material that we're using with the default 25 micron settings.
Sure, that's what it comes with.
Yeah, so the really cool WebGL type stuff that they're doing here for the web. You can sort of scrub through this to sort of look at what all the layers are going to be, and you can see the skull keycap that we're printing here.
Oh, cool.
You sort of scrub through that. And it works on iPhone too, or any mobile device, and it just plays back as a MPEG-4, I think.
Okay.
So that's pretty cool for being able to preview your print job there. Once you are satisfied with that, you can just hit the print, and that'll actually just send it to the printer, which is connected through Wi-Fi. Okay. Just load it in there. There's like I said before in the last episode, there's not a lot of when you connect to the computer, you can't like move it around or anything like that. There's not a lot of control in it.
And pretty much you set it up, you hit print, and that's about it.
That's basically all you have the buttons for.
You can run a leveling for the bed.
Yeah.
That's about all the setup you really need to do on the machine.
So after that, you can just check your progress on there by going to the website, logging in. And like I was saying before, you can just sort of load, it's just a MPEG-4 movie, so you can sort of scrub through all the layers. And it's pretty cool the way it's doing the, sort of telling it what frame to go to at, when it's done exposing and separating. You can check the status of it right there on the top left. And that's pretty much it. The workflow for that, a little bit different than what we're used to on sort of the FDM printers.
Oh yeah, vastly different. It is completely different. So we'll be doing more projects with it. Obviously, as we learn it and get more experience with it, we'll share that with you guys in the coming weeks. Very cool. You know what? I think that's going to be the show, Pedro.
Yeah, I think that's all we have for this week.
Yeah.
Don't forget to follow us on all of the social media. Check out the learn.adafruit.com to check out all of the guides.
Some links for you guys. Of course, all the projects you can find this project on the Adafruit Learning System. It is up there. It's actually been up there for a couple weeks. We just like to get it out early. You're going to definitely check out the Google Plus page. We actually have a show and tell every Wednesday at 7:30 Eastern Time.
Yeah, show off your 3D printer projects there.
Yeah, come on the show. You can share with us what you're working on or what you want to work on. We also do some retro tech.
Yeah, bring some old cool tech to show off.
It's very cool.
Every Thursday is blog day for us.
Yeah.
Check out all the 3D printed stories. Check out the 3D Thursday hashtag to check all those out.
Yeah, and then you can follow Pedro on NeoPixel and myself, Ekin, or Adafruit on Twitter and Instagram. We're there. We're always uploading photos. You've been uploading a lot of cool new photos, so that's really cool.
It's a little tough to get those photos with gloves and mask on, and feels like working in some sort of bio tech or something.
It's a little fumey. We actually cannot operate it in our studio. We actually have to operate it in the garage. So.
That's right. So follow us for some behind the scenes of progress on that.
Of course.
That's all we got for this week, guys.
Yeah, but don't forget, we got a coupon code.
Gamepad.
Check that out. Gamepad. And that's going to be it, guys. Thank you so much for watching. We'll be here next week. And until then, remember to make, share, and repeat. I'm Noe.
I'm Pedro. See you guys next week.
Bye.